Welcome to the third in the tutorial series on how to use the OCC Weather Centre. In this update, we're going to discuss radar. OCC purchases radar information from the Bureau of Meteorology. So the radars that you see on your screen are owned and operated by the Bureau of Meteorology. Firstly, that means that we're at the mercy of any issues that are going on at the Bureau of Meteorology with regards to any of these radars. So if they're out at the BOM, they're going to be out at OCC as well. Now, to access the radar imagery, you need to go into your layers button up here, your layers drop-down menu, and you need to make sure that radar overlay is clicked and enabled. As always, you can alter the opacity, so that's the see-throughness of the radar, and you can see here, the lower I drop this, the less dynamic the radar appears on your screen, the more see-through it appears. And that's often useful if we're combining radar with satellite coverage or radar and computer model data, for example. Many, not all, radars from the Bureau of Meteorology are available both in reflectivity and velocity imagery. So reflectivity shows us the rain falling at that radar level. Now, we do radar a little bit different here at OCC compared to what you might be used to at the Bureau of Meteorology. So if you look at the Bureau of Meteorology website, what you're looking at is around about 3 kilometres above the radar level and what the echoes are doing in the sky. We've taken a little bit of a different approach to what we show you here at OCC. So in the first 30 kilometres away from the radar, you're looking at about 500 metres above the radar level. Between 30 and 60 kilometres, you're looking at about 1,000 metres above the radar level. Between 60 and 120 kilometres, you're looking at around about 1,500 metres above the radar level. So just remember, this rain may not necessarily, the further away you get from it, may not necessarily be hitting the ground because the radar beam is beamed towards the vertical at some elevation. So the expectation is that the further away we get from the radar, the higher up into the clouds we're looking. And then once we get outside of about 120 odd kilometres, we're looking at 3,000 metres plus above the radar level. So we're talking about stuff that's going on way up in the atmosphere, and it's important to understand that process, because if sometimes we see things a long way out and we think that they're actually falling, or that rain is falling on the ground, and sometimes it is not. It is just falling from the sky, but it may not be hitting the ground, particularly some of this really light stuff that you're seeing way out in your screens. Now, obviously with radar, we give you all the different elevation, location range options, so you can go all the way down to 32 kilometres and have a really close view into your region. 64, 128, 192, 256. Once we get into the 192, 256, 512 levels, we start to merge the radars so that we combine all the different radars around to give us one fluid image. The OCC weather radar is available in various time frames, so you can see the loop at various time frames between 1 hour long and up to 24 hours long is the longest that we can show you, and we loop them every 5 minutes or so. So every 5 minutes is an added step to the loop. Now we've got different speeds that we can loop these at. So warp speed will give you an idea of what's happening really fast. Slow speed, if you're looking at a very short time frame, could be beneficial so you can keep a track on the individual cells, but just be aware it is very slow when we're looping, and we tend to want to loop at a little bit faster than that. I recommend using fast speed, light speed, or warp speed, especially if we're looking at those longer term time frames, so things like 3 hours or more, those loops, we'd want to be looking at light speed and warp speed so those things can happen nice and quickly, and we've got enough detail there to understand what's going on. At any time, if you want to pause the loop, all you do is click the pause button here and you can play around with what part of that loop you want to look at. Every time you change the loop duration, you may need to take a little bit of time for the images to load. And you'll see here an image loading percentage. Once the images are loaded, the loop becomes available again, and so you can click on the loop yet again. And in the merged imagery, what you're looking at here is what we call the maximum reflectivity that we've got at those different levels from all the different radars. So sometimes you'll find that rain from this radar might come into this radar and look much stronger or much lighter than it did back in this radar. And that's because we use the maximum reflectivity as opposed to the closest reflectivity. So there's some of the quirks of the OCC radar that you do need to be aware of. We don't merge the imagery from the velocity radar. So the velocity radars are on their own, and you can see here the velocity imagery reflects winds rather than rainfall, and it reflects winds coming towards the radar in red and orange and yellow, and winds moving away from the radar in blue, black and green. The deeper the colours, the stronger the wind. The deeper the colours in either direction, the stronger the wind. And also it's important to understand here that once again, we're not looking at ground level winds, we're looking at winds above the radar height. So the further away we get from the radar, the higher up we're looking into the atmosphere when it comes to the where those winds are occurring. So obviously if we're seeing these dark blues, it doesn't necessarily mean that we're getting 100 km/h winds at the ground level. It usually means that there's a certain elevation above sea level, and the further away we get from the radar, the higher up into the cloud we're looking for those winds, or the higher up into the atmosphere we're looking with those winds. So they're important things to note for the OCC weather radar.